Okay, while they're joining, I'll go ahead and just start. So my name is Rachel, if we haven't met. And today I'm going to be talking about some work that I've done while here at Hopkins, kind of throughout the years, starting with sentence level translation and slowly progressing towards context-aware machine translation, also called document level machine translation. And it's not going. So my mouse seems to be gone. I don't know if it's my laptop or if it's the Zoom. Let me try. It's like it's gone, but I can still kind of highlight things. I should try this. Does that work? Nope.
Do you want to try?
Oh, that's real. Oh God.
Stuff.
Yeah, no, it's not even Zoom. Oh. I think it just crashed. Let me just read. Oh, or Keynote crash. Let me just try to restart. Technical difficulties, please hold. Hopefully this is good.
-7.
7,
351
3, 5, 1,
83473.
8, 3, 4, 7, 3. Anything. Maybe it doesn't like this.
Yeah.
For some reason, it doesn't seem to like doing both.
Oh, now let's see. Okay.
Okay. So, straight into the second slide then. So to start with, let's look at the task of machine translation. So I have some input text here. I want to translate it into German. When I run this through some online system, what's actually going to happen under the hood is it's all going to freeze again. Is this text is going to be split into sentences. Okay. Hold on. Could I try to send you my slides and would that work? Because this is like, it's completely hanging when I try to share. I don't know why. Can you stop this shit? Or maybe I can try to, I don't know if it's Keynote or if it's my laptop or what.
Yeah.
But it's. We'll try your laptop, sorry. I hope that's okay.
Yeah, that's fine. Okay. I can't see my mouse, but it seems to.
Okay. Yeah, I don't know what the mouse is doing, but okay.
Let me close this.
All right, so back on track, hopefully. So again, I'm Rachel. So today I'm going to be talking about word Hopkins, sentence level to context-aware machine translation, etc. We have some input text. We want to translate this text to German. If I were to put this through an online system such as Google Translate, what's going to happen under the hood is this text is going to be split into sentences. Those sentences are going to be back translated. Those translations are going to be concatenated back together and then returned to the user. And in fact, we can see this is what happens when we put this through Google Translate. So Google has this nice highlighting feature where it actually highlights what the individual segments are and what part of that got translated in the output. But when we look a little bit closer at this output, what we see is that it actually segments UC Berkeley into two sentences because of this ambiguity with the UC acronym. And in fact, what we see further, if my German is correct, is that it uses the masculine form of the word author instead of the feminine form because the author's name, Christina, is now in the previous sentence and it has no access to that information. So if we see that there are errors in segmentation, and segmentation is such an integral step in the machine translation pipeline, we want to look at how it's interacting with the overall pipeline and kind of what errors it's propagating through the whole system. So if we look at the pipeline, what we start with is the curation of training data. So to create machine translation training data, what we first do is we identify machine translation, we identify parallel documents. These documents are then split into sentences. These sentences are fed into some aligner, and the output of that is bitext. This bitext is our training data that we'll use in conjunction with some training pipeline. And then the output of that pipeline is our trained model. Once the model is trained, during inference, we receive yet another document. We need to first segment it into sentences before we can feed it into our model to get translation output. So a lot of the initial work that I did is investigating kind of these two pieces of this overall pipeline and investigating what happens when you remove more errors from segmentation and what happens when you vary the segmenter that you use in each of these locations. So the TLDR of that is that at inference, you don't get a lot of difference. Once a model has been trained, that noise is kind of learned, and it doesn't matter what segmenter you use really. But in a different way, we see a lot more difference early in the pipeline when you use it to create your training data. And kind of more specifically, we found that really small differences in segmentation can produce really different training sets. And when you have really different training sets, you get very different models. We also saw some small indication that extra context or kind of unsegmented text might actually be helping the models. So if removing errors still creates these really different training sets and extra context is helping models, we might be asking ourselves if we should be segmenting at all. So let's revisit this machine translation problem in its current state, but reframe it for what it is. It's out of context translation. So I have this input here. Art is trying to become science. It deals with philosophy, sociology, and psychology, and desires to be a pedagogical resource too. It wants to be political, yet maintain the charisma of the underground, that is by being non-political. It wants to be a commodity. So whoever wrote this used this literary technique called anaphora, where essentially they just use a pronoun. Instead of repeating art, they use this it to refer to it. And when we're reading this kind of as a consecutive sequence in context, we understand as English speakers that it always refers to art. However, when we put this input through a machine translation system, it first is split into sentences, and then they are translated in isolation. So when a machine translation sentence confronts this second sentence, it has this pronoun it, but it has no way to understand what it refers to. The antecedent is in a different sentence. And kind of more specifically into German, it has three possible translations. We have a neuter form, a masculine form, or a feminine form. This is really common in languages that express gender, that you'll have 2 or 3 different options for something like it. And when we're asking the model to produce a translation, we're actually forcing it to choose amongst these options. And forcing it to choose means we're asking the model to make a decision without all the necessary information, because that necessary information is in the previous sentence. So we see this when we actually put this through, and this is a Google Translate output, that art is a feminine noun in German. So it takes this middle form V. But as we can see, Google Translate produces multiple forms for the it, depending upon what sentence it was in. So we see a mix of neuter and feminine pronouns in the translation. And this is a really specific example of a broader trend. So natural language is naturally ambiguous. Speakers are lazy. And when one language is more ambiguous, for example, by using a pronoun that doesn't express gender, that ambiguity must be resolved during translation. And in discourse, whether that's spoken language or text, ambiguity is resolved via context. So by translating outside of that context, it is impossible to resolve that ambiguity. So let's go over some examples of discourse phenomena. The first one is kind of what we just covered, gender translation or translation into a gendered language. So we have the sentence, "This rose came for you." It stands out in front of all the others. Again, we know that it refers to this rose. When I begin to translate this, these inputs into French, I see that this rose is a feminine noun. So when I translate it with a pronoun, I also need to use a feminine pronoun. This work has, or this kind of concept of gender translation has been studied in French, German, Russian, kind of a handful of languages by a variety of people. What's interesting about this particular phenomenon is that it's also ambiguous in reverse. So I have this rose in French, and I have this feminine pronoun. If you took a French class growing up or any other kind of gendered language class, you probably learned that elle, for example, or ella translates to she. But when you begin to translate this whole phrase into English, we see that this rose is an inanimate object, and inanimate objects typically do not take she as a pronoun. So we instead need to use an inanimate pronoun and kind of resolve that elle in this case is referring to an inanimate object to correctly translate into English. Another way that English creates ambiguities is through ellipsis. So ellipsis is kind of just this concept of removing words, again, kind of out of like a brevity or like shortening. So for example, I can't lose my voice. I might reply, you won't, where the entire phrase is you won't lose your voice. But of course, because the verbs are very segmented in English, I can just get rid of the second half of that verb phrase. And I just keep this auxiliary here, you won't. A lot of languages don't allow this type of ellipsis. So this ellipsis, for example, is not possible in Polish. So when I translate this first sentence, I can't lose my voice. I'm translating this verb lose. And when I translate the second sentence, you won't, I'm once again translating the verb lose, just in this future negative kind of tense. Another example, I can't work with the Knicks right now, and other athletes. So again, I've ellipsed part of this phrase, and actually I've left it to kind of just a noun phrase. It's not a complete sentence anymore, but I understand what role athletes is functioning in. The big reason this is difficult in English is because word order conveys syntactic roles. So based off of kind of the ordering of nouns and verbs, I understand whether something is a subject or an object. If I reverse that ordering, all of the rules become reversed as well. So if I remove the verb from the sentence, I've also removed that ordering, that relative ordering. But the ordering is still implied from the previous sentence. And when I have fewer words, the word order is more ambiguous, and thus the syntactic roles are more ambiguous. Some languages do not use word order to express this. So for example, Russian uses inflections, which just means that they mark that syntactic role specifically on the noun. So this noun is inflected in this case in the instrumental case. It has some marking associated with it to designate that this is an instrument in this example. And when I translate athletes, I need to use the same marking, even though the verb phrase that associates it with an instrumental case has been removed. The last case is a little bit different. It's still interesting because it doesn't have a clear context that resolves it, but I think we're all familiar with this idea of formality. So in English, we have this word you. I use you regardless of whether or not I'm talking to a singular person, multiple people, my professor, my friend, my mom, anything. But in many languages, there's different words for each of those options. So you need to kind of distinguish based off of context clues or something else, whether or not the relationship is a formal relationship or an informal relationship before translation. This is also something that's been studied kind of extensively. So if we understand that there are problems translating at the sentence level and we understand what those problems are, let's go ahead and just start training context-aware models and seeing what we can do with them. So what we might do is go to a common data source for MT data, Opus. Some of you might have heard of it, but what we immediately notice is that of the top 10 largest data sets on Opus, 8 of them are sentence level. And beyond the fact that they're sentence level, they've removed any sort of document data that might suggest the document ordering or give us the ability to construct context from this data. And even if we had this data and we're looking for ways to evaluate a model trained on it, we're immediately going to be confronted with the fact that the data sets available for these phenomena are pretty sparse. And really specifically, what we notice is that a lot of the work is focused on this gender phenomenon because it's kind of this typical one that everybody thinks of. And to the best of my knowledge, little to no work has been done into English, let alone in non-English language pairs. So there's these obstacles in the way of actually pursuing context-aware machine translation. So we have, no data sets, both in terms of evaluation data sets and training data. And then a second point that if you think critically about the training sets problem is that all training sets for machine translation are web crawled, and a lot of web crawled data is machine translated. So any sort of context-less machine translation that is applied is going to creep into your training data as well. So first, let's confront this problem of evaluation sets. So let's go through this example of gender again, where I have kind of these 4 phenomena. And in order to produce an evaluation set, what I want to do is be able to widespread identify where these phenomena occur in order to kind of tag a lot of examples to be used for evaluation. And in this example, I kind of underlined these 4 terms, and I also did this for the other phenomenon, where these 4 terms kind of define this level of ambiguity. It's specifically the relationship between it and L, and it and its antecedent, and L and its antecedent, that determines that this is an example of an ambiguous gender translation. So what we're going to do is kind of abstract away these terms, and instead we're going to refer to them as words or spans, where the input has some word or span in this relationship, and the previous context has some word or span in this relationship. And what we can do is craft rules to not only identify which word or spans each of these terms are, but also kind of constraints that they have to meet in order to be considered an ambiguous example. So an example of how this would actually work in practice. So on the left, we have an example of English bitext, and then it's aligned to its French bitext. This is in document order. So the first check, if we're looking for an example of a gendered pronoun translation, is does my English contain the word it? This is just a surface level matching. It is in the sentence. In order for this to be an example of pronoun translation, this word has to align to one of the French pronouns. And in this case, it does. We see that it aligns to the French elle, which is a feminine pronoun. And it aligns to it via some word aligner, and we verify its correctness with this surface form matching. Now we need to check the context. So because this is gender, or this is gender translation with pronouns, the context that we're looking for specifically is its antecedent, Luckily, this is already a task in NLP, which is co-reference resolution. So it refers to a statute, and we can find the span based off of some co-reference system. Now, in order to find the French antecedent, we look again at the alignment to find that a statute aligns to une statue. And we check that une statue is also a feminine noun. And now we have it and an antecedent that is a feminine noun in French, translating to a feminine pronoun, and we verify that this is an example of a gendered pronoun translation. So when we apply this pipeline to a data set called open subtitles, which is kind of standard practice for these type of evaluation sets, we find a lot of examples. So in the green, or the more right bars, these are the number of sentences where any of the phenomenon have been flagged. But what I'd like to point out is that these are mostly formality. So any sentence that contains you in English is difficult to translate into formal languages or languages that express formality. And that's a lot of sentences, especially when you're looking at subtitles as a data set. But more specifically, some of the categories, so auxiliary and gender is denoted by these blue bars here, and you can see they're much shorter. And in fact, they represent about 1% of all sentences in open subtitles that contain this ambiguity. And the reason this is important is because this is kind of a rough stat for how often this occurs in language. So 1% is kind of a lot when you're looking at millions of sentences. But if you're looking at an evaluation set, 1% is not a lot. So if you're taking the machine translation test set of the year from WMT, and you're assuming that 1% of those sentences actually are ambiguous, then that test set is not really robustly testing any system for the translation of gender or the translation of auxiliaries. So this is kind of reiterating the need for evaluation sets that densely represent these. So once we have these evaluation sets, we need a way to kind of make sure that they actually contain this phenomenon and make sure that, a sentence level system is not outperforming a document level system. So we're looking for a document level model to run against these tests. So unfortunately, we can't just run it through Google Translate or Microsoft Translator, because as we saw earlier, most online translators will segment the input first, and we really can't stop that from happening. We also can't train our own model because there's not a lot of document level data available. So there's kind of one option that's left for us, which is what most people use for something like this, which is a commercially available system called DeepL. And per its own documentation, it uses context to translate. That's kind of all we have to go based off of. So now, once we have a model, how are we going to evaluate its correctness? So prior work has done this mostly in a discriminative way. So given the correct answer and the incorrect answer, does it give a higher probability to the correct answer? What we're going to do instead is a slightly newer suggestion, which is generative accuracy, simply because discrimination is an easier task. If you give the model the right answer, it's going to assign it a higher probability. That doesn't mean it's going to produce it when you actually ask it to translate. So the metric itself is very straightforward. It's an accuracy. You get a point if the expected form, so in this case, one of the pronouns, is in the last output sentence, and you get no credit otherwise. So now if we look at the actual results. So the first is where our online system only receives the sentence. So this is going to kind of give us a baseline for random guessing, majority class guessing, if there's some sort of context clues in the sentence that isn't the antecedent, or even if the antecedent is incidentally in the same sentence. Then we compare this to if we give the online system multiple sentences of context to see its improvement. And what we see for the gender is that we get quite a lot of improvement when we give it just a little bit of extra context, 20 points in some languages. And not only in gender, but we see this in multiple categories. So animacy, formality, inflection, and we see it really dramatically with the auxiliary class. So we can kind of check off this first. We have solved the problem completely, obviously. No work left to be done of evaluation sets. And we can now move on to training data. So the problem with current training data is that bitext removes document structure. So without going into too much detail about how machine translation bitext is generated, if we think generally about the alignment step, sentences are going to be unaligned, they're going to be skipped, they're going to be removed from that output. Alignment may or may not respect document boundaries, so you might kind of treat all sentences as a bag of words and align kind of arbitrarily. And then mostly before these resulting products are released, segments are shuffled and deduplicated, which is going to completely destroy any context that is remaining. So the end goal is if we have some bitext here on the top and we have some kind of sentence pair, we want to identify specifically where it occurred in the original monolingual document. And this is going to identify when we have two consecutive sentences, where consecutive sentences then are part of the same context, or two sentences actually are very far apart from each other and have nothing to do with each other. So for this, we turn to paracrawl as a data set to reconstruct this information. Paracrawl is a web crawled corpus for European languages, mostly paired with English. And the reason it's desirable is because it mines sentences by first aligning documents. So it's going to maintain that document structure. After that, it aligns sentences. And then it slowly filters out through more aggressive techniques and eventually removes context altogether. However, the version where they just align sentences and discard no information is publicly released. And about 2/3 of the monolingual sources are also publicly released, which means that we can match these segments to the original documents to get that context that we desire. So we do this for a few different languages with paracrawl. And basically what we're going to do is we're going to just kind of figure out what these indices are for kind of exactly where it occurs in the monolingual document. And then when we have two consecutive sentences, we can figure that out based off of the indexes. And by indices, I literally mean like string indices of exact matching. So after we do that, we extract documents. So a document is a context in this case, and this is at least two consecutive sentences. And because we haven't done any filtering on this, and this is the unfiltered, we also have these two little things that we do, where each sentence has to be at least 0.5 probability in the correct language, and each sentence occurs less than 100 times. So this is going to get rid of that boilerplate stuff, home, about us, contact us, all of those kind of templatic things that show up in bitext. But wait, we've done no quality filtering beyond that, and a lot of the alignments might be bad. And as I mentioned at the top, a lot of web text is machine translated anyway. So if we do extract context from this, they might be machine translated, and we don't want to distill Google Translate when training our models. So we need to investigate document filtering. So there's two recent works that we're going to kind of combine together to achieve this. The first one is a technique for evaluating document phenomenon, specifically at inference time. And the second one is looking at quality estimators. So just given an input and given a translation, no reference involved, can you give me a quality score on that? Showing that this kind of technique can be used for MT data filtering. So quality estimation, generally, the way it works is you give it one sentence of source and one sentence of target, and you ask it to give you some score. And you do that individually for each sentence in your evaluation set. Then to come up with an overall document score or an overall system score, you just average these across all sentences. The way slide works is it gives it a context window. So in this case, we would give Comet Kiwi 3 sentences of source and 3 sentences of target, just concatenated together. And again, ask it to produce one score. And as the name suggests, to create the next score, we just slide the window down. We still take kind of all of these scores and average them together to come up with an overall document score. So once we use this method to score all of our documents, and the goal of this is that Comet Kiwi is going to rank something like this with very consistent pronoun usage because it gets to see the pronouns used in context, higher than something like this that Google Translate produced because it uses these inconsistent pronouns. So once we score all of our documents, we're going to sort them. And to filter, we're going to filter out some bottom percent. So we have 4 filtering levels, one where we don't filter anything. Then we have loose filtering where we keep the top 75%. Medium filtering is the top 50, and then strict filtering is the top 25. And what we're hoping with this method is the top is not only well translated, but also that it's not machine translated, so that it doesn't have a lot of examples of these inconsistent or these context inconsistent translations. So if we look at the quantities, I want to highlight first off this gray bar. So this is original paracrawl, unfiltered. And then I want to highlight that this is log scale. So there's over 10 billion sentences in the original paracrawl, and most of it is garbage. So when you actually start extracting text from it, extracting context with these like deduplication techniques, this is where you get about 160 million sentences of actual context. And then kind of for comparison, just as a note, the APARCOL official release is about 250 million for English German. So this is kind of the range that we expect. And then each subsequent bar, as noted previously, is about 25% less data. So to train a document level model, we're not doing anything fancy with like, how do you best incorporate context? How do you signal to the model what context is important? The simplest technique that people use to achieve good results is you just concatenate sentences together. So on the bottom, we have this one stream of documents where sentences are just concatenated together with an EOS token and fed into the training pipeline. We also supplement this with regular bitext, again, because our data quantity is a little bit limited in kind of the strictest filtering sense. We still want the model to be able to learn general machine translation, the sentence level tasks. So we give it a supplementary bitext sentence level data set, and we just mix these streams together during training. So the training or the machine translation model will see both sentences and documents during training. So first we look at the overall performance. So by overall performance, I mean this general translation task. If I were to submit this system to WMT, what would its blue score be on some general domain? So our first model is this gray bar. This model somewhat corresponds to that very large bar raw, except I processed it using really traditional sentence level filtering techniques. So the deduplication, the laser filtering, the lang ID, all of that stuff. And it's roughly the same size as the APARCOL official release. So this is basically what you would do if you had exactly this data, but it was all sentence level. And as we can see, it is the least performing model in all cases. And the other 4 bars are all some variety of a document level system. So the loosest kind of unfiltered criteria still produces better results, but obviously leaves a lot to be desired when we're looking at the more aggressive filtering methods. And then in this general domain, we do see kind of a top off in this medium filtering level. So once we start too aggressively filtering, we seem to be losing performance. 2 notes here is that one, each of these bars have kind of this increased performance, but they're trained on much less data. So they all have the same supplementary bitext, but that document level data is reduced each time. So when you see the difference between the blue bar and the black bar, this is quite significant because the model saw 25% less data. So now we've kind of validated, all right, context-aware models do not hurt translation, and in fact, most cases, they seem to be helping. But what about the actual question of these discourse phenomena? How are they approaching this? So translation is much better for context-dependent phenomena. So again, we still have this black bar, or sorry, this gray bar here, but all of the other models are doing much better than it. Formality is kind of an odd case, again, because there's not a specific cue to pick up on in the context, but in gender and auxiliary, we see these really clear trends where the results slowly improve as you get more aggressive filtering. And we don't see this drop off anymore where we, yeah. Yeah, so docs is unfiltered. It's just all of the context. So this is like basically all of the data treated as sentences. This is the data unfiltered, but it still has context. Slightly filtered, more filtered, most filtered. Yeah. So the key thing to note here is that on the previous slide, we saw this drop off after medium. So when we got too aggressive with our filtering, we started to lose performance. In this case, when we're specifically targeting phenomena, we don't see that. So to me, this kind of says this filtering technique is ranking context features very high, even if the data quality, or sorry, the data quantity might be limiting the overall performance. So now we kind of have checked off this second bullet. And instead of checking off the third bullet, I'm kind of just going to leave us to ponder, and this is my area of future work. How do we approach this area of, or dealing with the fact that web call data is highly machine translated? And in fact, there was like quite recent work showing that the more parallel your data is, the more likely it might be machine translated, kind of depending on the domain and exact website. And we have this document filtering that we've done here. But we don't have a lot of evidence to suggest that it's actually getting rid of machine translated text besides kind of that last slide, which is like very lightly implying it. So kind of two areas to look at is one, is there a good way to detect machine translation on the internet, specifically with respect to being inconsistent in context? Or with the advent of large language models and the ability to do synthetic data creation, is there a way to avoid the web crawled data altogether so that we definitely know kind of the origin of the data? And then that's all I have. So if there's questions.
Sort of when you were quantifying the amount of data that the census level versus the document level had, were you doing like tokens or like number of examples? Like how are you saying?
So these slides are specifically this is specifically sentences. I also have results for like how many documents there are. The document length varies based off of kind of the website of like, is it really just that two, or are there like 4 or 5 sentences? So I think it averaged out. They were mostly the same, but I think the higher filtered ones did tend to be a little bit longer, but all of it's in the range of like 3 to 5 sentences on average. Yeah, I don't think I've chosen count though. Yeah, and then the filtering percentages is the number of documents, so the sentences vary a little bit more, but yeah. Yeah, so that kind of goes back to wherever this slide is, this, of like, how far back is that antecedent? So it's a little hard to determine. So when we ran this, we gave it up to 10 sentences where like you can find an antecedent up to 10 sentences back. And you definitely find them. Most of them are going to be the sentence before, the sentence just before that. I think this is in part because like too long of context, the speaker or like the reader might also get confused. But also you tend to re-refer to things. So you don't say art and then it, you might say art again. So it kind of interrupts that flow. But one problem that you have with creating these long contexts is like this co-reference alignment. If you're using an automatic technique, this co-reference alignment is going to introduce more errors, kind of the longer context you give it, because you're giving it a lot of options. Whereas it's like really accurate and like this like range. So the answer is it might be quite a lot of context, but a very little context can help. The other aspect of this is like we're not leveraging kind of any context length that transformers are capable of. So if machine translation is happening like roughly at the sentence level, you're talking about like 10 to 20 tokens. And transformers have like far moved beyond that. So even giving it something like 256 tokens, you're looking at like 10 sentences. And nobody's doing a lot in between. So we're kind of underutilizing what transformers are even capable of like very minimally doing without any sort of intervention. Yeah.
It seems like a lot of the categories like gender, intimacy, formality, they're translated into a language that like doesn't really express it in a language that has maybe 2 classes.
Yeah.
Are you aware if people have investigated like so some languages have a large number of word classes, at least in gender, or maybe an express number in more than just 2 things?
Yeah, so there's 2 threads on this. One, I don't think a lot of people have done it, mostly because these techniques are mostly automated. So you're looking at typically lower resource languages that may not have stuff. So there's 2 veins that I kind of thought about pursuing and kind of pursued and then didn't. So one is English doesn't express gender. German and French do, for example. Their genders are not aligned because they're kind of arbitrary like noun classes. Even with like French and Spanish, they wouldn't be aligned. So in that case, you can do something similar, but some of these tools, so like co-reference is going to be weaker if you're applying it to not English. So we did try to apply English as a pivot, but then you're very dependent on like multi-way parallel documents, where you can create like German, French gender ambiguities. The other vein of this was like Swahili is like an option for like it has a lot of noun classes, and you probably have to figure out what the noun is because you have now like 16 options. And there's not as many tools for kind of labeling those, or like, you might have to get quite specific. In like, I'm specifically looking at, English into Swahili translation, and here's my custom pipeline for that, rather than something generic, which covers a lot of phenomena in a lot of languages. But I don't think too many people are specifically looking at creating evaluation sets for widespread phenomena like that.
I have another quick question, which is that I think one of, like, as far as I'm aware, one of the cool possibilities with LLMs is better document level information. I don't know if you're aware of that.
So I haven't investigated too much. It's kind of like the next thing, which I had on that next point of like, what can you do with an LLM? I think if you push, and you're familiar with this, if you push the language that you're using too much, or like the resource level of the language that you're using too much, you're going to suffer in results. I do know that they do address some of these phenomenon better than like your run-of-the-mill Google system, but I'm more interested in it being able to like generate grammatically consistent documents to begin with, because you can utilize that in like a back translation system better.